Okay, so you are welcome to another session. Today we'll be looking at the fourth law of indices. Okay, so we look at the first, second, third, and today we'll be looking at what the fourth law of indices. Okay, now when you look at the fourth law of indices, we have a, right? We have a to the power negative m, which is equal to 1 over a to the power m. Now, anytime you have an index or when you have a base carrying a negative power, we always find the inverse. When I say inverse, it means that we have 1 over the base of the indices. Okay, that's what we call the inverse. We always find the inverse of what? The indices. Okay, so when you look at this, we have a to the power negative m, which is equal to 1 over a to the power m. Okay, so it means that we find the inverse of what? Of the indices. Okay, so a to the power negative m will give you 1 over a to the power m. And likewise, when you have 1 over a to the power m, you have your result to be a to the power negative m. It means that they all work inversely. Okay, so a to the power negative m will give you 1 over a to the power m, and 1 over a to the power m is equal to a to the power negative m. Okay, so it means that anytime you have a negative an indices with the power negative, you have 1 over that same indices. And also when you have 1 over a to the power m, you also have a negative of what? That indices. Okay, so they work hand in hand. Okay, now we are going to look at examples. Okay, we'll look at examples or scenarios concerning how to apply this fourth law of indices. Okay, now when you look at example 1, we have 1 over 27. Okay, if you want to simplify this by applying the fourth law, it means that we need to get the index notation, right? The index of the factor, the prime factors, or okay, let me say prime factors. We need to get the prime factors of 27. Okay, so for us to get the prime factors of 27, it means that we need to apply the factor tree. Okay, so here is the factor tree. We draw it 3 3 9. We broke that 9 down. We have 3 3. Okay, now when we pick the prime product, we realize that the prime numbers in this factor tree, they are 3, and the trees, there are 3 of them. So you pick all the 3. So 27 will give us 3 to the power 3. Okay, now when I brought it back, you have 1 over 3 to the power 3. Now per this law, anytime you have 1 over a to the power m, will give you a negative of a to the power m. So in this instance, I'll have my answer to be equal to 3 to the power negative 3. It means that I'm applying this law, 1 over a to the power m, which is equal to a negative m. Okay, now let's look at the second example. Okay, now the second example, we have 2 to the power negative 3. That will give me, which is equal to 1 over 2 to the power 3. Now, 2 to the power 3. 2 to the power 3 doesn't mean 2 times 3. It means 2 times 2 times 2. It means you multiply the 2 3 times. Okay, so 2 to the power 3 means 2 times 2 times 2. Okay, 3 times. And we know 2 times 2 times 2 will give us what? 8. Okay, 2 times 2 times 2. 2 times 2 times 2 will give us 8. So it means that 1 over 2 to the power 3, the result to be what? The result to be equal to 1 over what? 8. Because 2 to the power 3 is 8. Okay, so that's it.